Fantastic. Well, look, good afternoon, everyone, and thank you for coming to my talk on serverless architectures. I know that I'm the last man standing between you, the final keynote, and the party. So look, I'll try to be quick, I'll try to be light, and hopefully make it fun for you. We have a few notable guests in the audience, like Martin, so that doesn't make me nervous at all. But look, I will tell you a story about my serverless startup. And I will tell you some of the lessons that we learned, where we succeeded and where we failed. I think that a serverless approach to architecture is the future, but it is also not a silver bullet in all circumstances. There are some interesting problems that still need to be solved, but it is an unbelievable accelerator if used wisely. So just a quick question before I start. Who has heard or used of AWS Lambda? Excellent, I think we've done this before. What about Azure Functions? Yep, that's the usual response that I get. This is recorded, right? Oh. What about IBM OpenWhisk? Yeah. And what about Google Cloud Functions? Cool, okay. So look, my name is Peter Sbarski, and I'm VP of Engineering at a company called A Cloud Guru, and our mission is to teach the world cloud computing. So I'm also the head organizer of a conference dedicated to serverless architectures and technologies, and this conference is called ServerlessConf. So both Chris and Mike, who presented just before me, actually attended and presented at ServerlessConf last week. So this is how much both of them love serverless. You know, after that conference, they immediately came here to present to you today. So thank you to those guys. They are amazing. I have a background in computer science. I got a PhD in comp sci in 2008. I worked as a consultant in Melbourne, Australia for a number of years. I worked for the Defense Science and Technology Organization and the United Nations in New York. My interest is in cloud, software architecture, and over the past couple of years, I've spent quite a lot of time kind of trying to understand what this serverless thing is all about. And finally, I'm the author of this book. It is called Serverless Architectures on AWS. So if you are interested, come and talk to me after my talk. So let me set just a little bit of context before we go any further. So here's a little story about our startup. So at the start of 2015, we put some courses on udemy.com teaching people about AWS, right, and helping them to achieve certification. So the whole thing went a little bit crazy. A lot of people seemed to like our courses. And so after a while, we decided to build our own online training platform. We think that learning is a social thing. And so we wanted to build the best possible place online for training. We wanted to provide interactive discussions, gamification, and just make kind of learning and training a lot of fun. And so in 18 months, we have scaled to 200,000 engineers globally across 140 countries. At any given time, there can be thousands of people using our platform, watching videos, doing quizzes, interacting with each other, all in real time. And so our system is completely event-driven and push-based, going to the talk, to the keynote this morning. This means that as people interact, these interactions are pushed immediately to all the devices worldwide. And we don't run a single server. Not one, not anywhere. In fact, our hosting bill is almost non-existent, and I'll tell you what it is a little bit later. And so the main point that I want to bring across to you is that what we have built is not just like a toy application. It is a fully fledged, rich web application in production that powers with thousands of simultaneous users at the moment. Now, there are other examples that I can tell you about other serverless systems, like Expedia, that triggers 1.2 billion serverless requests a month. FINRA, the Financial Industry Regulatory Authority, processes 500 billion validations of stock trades every day, so on and so forth. So there are a lot of examples. So look, this wouldn't be a talk on serverless if I didn't tell you what serverless is, right? I think this is a tradition. I had to say, yes, there are servers, absolutely, yep. So here is my definition of serverless. So number one, a system is serverless if obviously there are no servers for you to manage or administer. Instead, you use an ephemeral compute service that, given a small piece of code, like a function, will execute it for you on demand. Right? So some people prefer to call that function as a service, which is totally understandable. Next, serverless applications typically use third-party services to help with tasks such as authentication, database, file storage, and so on. And we can call that backend as a service. Look, obviously, it isn't mandatory to use third-party services, but we find that a lot of serverless applications do. Finally, there are certain patterns and architectures which are common to serverless systems. So for example, thick, powerful front ends that communicate directly with other services using JSON Web Tokens. Serverless applications are typically event-driven, and so on. And I will talk more about these patterns and architectures a little bit further on. So in my view, serverless is a theme, right? It's an approach to building software, and it's made out of compute and patterns. So this is interesting. Just this morning, I had a look at the ThoughtWorks technology radar, and it is really cool. So they put serverless architectures under trial, which means that this approach to kind of software design is mature enough for teams to begin trialing and exploring in more depth. So that is very cool. Let me talk about AWS Lambda just for a minute. So Lambda is Amazon's serverless compute service, and it's definitely leading the game right now. And it works very simply, right? So you create a function, zip it up, upload to Lambda, and Lambda will execute that function for you in response to some event, right? It could be an HTTP request, or it could be a file placed in an S3 bucket. So an event will happen, and that can trigger a Lambda function that can do some processing. So I say that Lambda is groundbreaking, and it's as big a shift forward for cloud computing as S3 was for cloud storage. And in fact, if you think about it, the two are very, very similar. So Lambda is to compute what S3 is for storage. S3 deals in objects for storage, right? You provide an object, and S3 stores it. You don't know how, you don't know where, and you don't care. There are no drives to concern yourself with. There's no such thing as a disk space. Not enough space, no such thing as too much unused space. These concepts do not exist at all. You cannot over-provision or under-provision storage capacity in S3. It is just what you want it to be. S3 stores and charges you exactly what you give it. Nothing more, nothing less. So if you look at Lambda, it's the same thing, right? Lambda deals in functions for execution. You provide function code, and Lambda executes it for you on demand. You don't know how, and you don't know where. You don't really care. There are no virtual machines for you to think about, no such thing as a server farm capacity, too many idling servers, not enough servers to meet demand, no scaling groups. These concepts do not exist at all for you. So you cannot over-provision or under-provision compute capacity with Lambda. That's interesting. It is just what you want it to be. And Lambda executes and charges you for exactly what you execute. So nothing more, nothing less. So this is why I think that Lambda is the next level for cloud computing. And it's as big a shift for compute as S3 was for storage. But Lambda isn't the only player in town, right? So we have other serverless compute technologies. We have Microsoft Azure Functions. We have Google Cloud Functions. We have IBM OpenWhisk. We have Auth0 Webtask. So other cloud vendors are jumping onto this as well, because I think they are seeing something here. They're seeing maybe the future in some way. Kind of while we were building our platform, we came up with a number of principles for serverless architectures that I kind of want to share with you. And I would love to hear your feedback. Does this resonate with you? Do you think that they're right? Do you think that they're wrong? So after this, please let me know what you think. And I will kind of just quickly mention each principle, and then I will illustrate with an example from our own system. So I guess, look, this is probably the most important principle if you're going to build serverless applications, right? Use a compute service to execute code on demand, AKA don't run a server. And this is probably the most important principle. Look, you don't want to run or manage a server if you don't need to, right? Your goal is usually to solve an interesting problem. It's not to patch Apache or install another security update. You can write functions to carry out almost any task. You can read and write to a data source. You can perform a computation. You can do pretty much anything you want. Another cool thing about a service like Lambda is that you are only paying for the time that your code executes. That means you are billed in milliseconds, not hours. And this can massively reduce your hosting costs. Yes, there are exceptions, yeah, but you are not paying for service to sit around idling, waiting for requests to come through. And it's interesting that, in fact, due to a generous free tier that AWS provides, we haven't actually paid for Lambda as yet. So don't tell Amazon. Is Chris in the audience? Chris, don't say anything, okay? And that's for 200,000 users who are hitting the system. So that's kind of interesting. Of course, there will be scenarios where you may need a server. I totally understand, but try to minimize your dependency on service as much as possible. So look, here's a basic use case where Lambda serves as a backend for, let's say, a web application. So you have a client. It could be a web application. It could be a mobile app. A request comes through to the API gateway, which is another service provided by Amazon. API gateway invokes the right Lambda function. That Lambda function can process your request. It can call out to other services. It can talk to, say, DynamoDB, or really to anything you want. It doesn't have to talk to services only within AWS. You can call out anywhere you want. It can generate a response and then send that response back to the client. So your client doesn't actually know that it's talking to a serverless system. Security can be taken care of at the API gateway level or at each function. So I would suggest doing both, but again, it depends on your requirements. So here's another scenario. So I call this computer's glue. So this is where you use Lambda functions to glue other services together. So you might have some storage, like file storage in S3. You might have a simple notification service or, I don't know, relational database. And you can glue these services together. And you can create awesome scalable pipelines where you push data across, perform certain operations, and you can do it all in an event-driven style. And I'll show you an example in just a minute. Number two, write single-purpose stateless functions. As software engineers, we are aware of the single responsibility principle, right? A function that does one thing is more testable, it is more robust, it leads to fewer side effects. And by composing and combining functions and services in a loose orchestration, you can build complex backend systems that are still understandable and easy to manage. Also, a granular function with a well-defined interface is also more likely to be reused within your serverless architecture. When you write code for, say, a Lambda function, remember to create it in a stateless style. You must not assume that any resources will kind of survive beyond the immediate session. So statelessness is very powerful, and it is actually that magic sauce that makes Lambda and other compute services possible. It allows these platforms to quickly scale to handle that ever-changing number of incoming events or requests. And look, often it is very hard to know where the granularity of a function should be, right? You make something too granular, and then you have an explosion of functions that you need to manage. God, it's a nightmare. And then you ignore granularity, and you've created mini monoliths. also a bad idea. And look, it takes time, I think, to kind of understand where the right granularity should be. We've tried to focus on giving each function one purpose. There's other thinking that says that each Lambda function should do 0 or 1 data transformations, but no more. And so Paul Johnston suggested that. When you write a Lambda function, only do 0 or 1 data transformations. So that's interesting to keep in mind. But for example, in our system, we have functions that allow users to submit questions and comment on our forums, or submit answers on our forums. We have a function that allows a person to vote up and down a question on our forums. We have a little Slack bot called GuruBot that informs our lecturers how much money they have made each day. We have a function that's responsible for taking payment. And we have a function that grants users access to restricted files. Third principle, and this is my favorite. It's about designing push-based event-driven pipelines. And look, they are powerful, and they allow you to extend your architecture really simply, and they look like magic. So an event-driven pipeline, in my nomenclature, is basically this. You kick off an event, and that event continues to propagate further without any additional user input. So very simple. One event triggers another event. So here is a very basic example. We use a NoSQL database called Firebase. And it is a real-time streaming database which uses WebSockets. So changes made to the database are synced to all clients in real time. So you make a little change in Firebase, and all of those changes are pushed to all web browsers connected to our website. So in this example, a user, I think that's me, submits a comment which goes to the API gateway. API gateway invokes a Lambda function. That Lambda function makes a change to our Firebase database. And that change is immediately pushed to all clients. That's kind of cool. Totally event-driven, there's no polling. Everything is kind of push-based and happens one by one. You could technically even simplify that further. You could have Peter update Firebase directly from the browser and have that pushed to all connected clients. Now, this may not be a good idea in all circumstances, but there are circumstances where this actually works too. So here's a simplified example of our video transcoding pipeline. We allow our lecturers to upload videos, so they record a course, awesome. We allow them to upload the video, which then gets transcoded to 20 different formats. So a video can be transcoded to 720p, 1080p, HLS, WebM, etc. And so here's what happens. So our user, so our lecturer, from their browser, uploads a file straight to S3, right? There's no intermediate server there. So file goes to S3. Once the file is uploaded, that automatically invokes a Lambda function, which goes, hey, there's a new file in the bucket. Cool. That Lambda function then sets up an Elastic Transcoder job. Elastic Transcoder is another service in AWS, which can transcode videos to different formats. So Elastic Transcoder receives this new job and goes, hey, awesome, let me do this processing. It spends, let's say, half an hour working and producing these new files. The new transcoded files are then placed in another bucket. Now that pushes an event onto the SNS topic that we have, which then triggers, basically fans out and triggers a number of other Lambda functions that we have. One of those Lambda functions goes, hey, cool, there's a new transcoded file. It updates our Firebase database, and all users basically in real time receive that update. So a new thing or notification pops up, or they see kind of a new lesson added to the list of lessons that they have. And this happens basically as quickly as possible. So there's no polling, there's no refreshing. This is all push-based, kind of end-to-end. That is really cool, and it works very well. So this principle gets me in a lot of trouble always. And I get a lot of debates, and anyway, I'll be very interested in hearing what you have to say about this. if you are creating a web application with serverless architectures, for example, I would suggest to you to create thicker, more powerful front ends. So what do I mean by that? So let's think about a traditional three-tier approach. So you have a web browser, which is your presentation tier. You have your web server, which is your logic tier, and the database, data tier. And so this layering keeps a nice separation of concerns, but it becomes very tedious to maintain and improve. And it gets even worse in the world of rich single-page applications. So let's have a look at this. You are all familiar with this approach, right? So in a single-page app, you have your whole framework in the browser with views, routing, maybe controllers if you use Angular, services, components. Your SPA talks over the wire and sends messages to your server, right? There you have to authorize all calls, validate input, fetch models from the database, apply business logic, so on and so forth. And then if you have to add a new feature, you may have to go and touch each of those layers. And I worked on projects that had 10 layers. I had managers and proxies and all kinds of things. And adding a button becomes really, really difficult, which isn't a lot of fun. But with the explosion of cloud-based services and great security mechanisms like CORS, JWT, SAML, something new becomes possible. Your front-end app can talk directly and securely to a number of cloud-enabled services. It is really interesting. And you can even talk directly to a database. And that may not be a bad thing in some circumstances. But this makes it possible to remove the middleman. It's interesting that this new model means that most of your data transformation and business logic could actually be moved to the front end, right? But of course, we are sensible people, and we understand that there are a lot of actions that cannot be performed in the front end, right? There are security concerns that you have to think about, privacy concerns, yes. And for that, you do have to still use something like AWS Lambda to execute code in a protected manner. So for example, let's say I want to notify all subscribers of my system that there's a new forum post. You would never, ever, ever do that from the front end, right? It can fail. You may have issues. It's insecure. You cannot load other people's email addresses into somebody's browser. That's a big no-no. So for that, you would use a Lambda function, right? You would execute that action from a protected function. So you get to something like this, right? You have a lot of richness in your front end. You can talk possibly straight to your database, maybe. And you can invoke cloud functions when you need to perform certain protected actions. Now, again, this works for a web application. This isn't going to work if you're building an API, for example. And again, I'd be very interested in hearing your thoughts after this. And now the fifth principle is about using third-party services. And look, we all know that there are companies that dedicate 100% of their time to doing some very specific things very well. So you have Auth0 that do authentication and authorization. You have S3 for file storage, CloudFront for CDN distribution, Firebase for data, Stripe and PayPal for payments. Each of these companies do what they do very, very well. So you can pick up a lot of speed by outsourcing some of the work that you have to do. And then you can focus on your core product, which gives you that additional acceleration. Now, again, this is easier for me to say because I work in a startup, so we can do this. It's a greenfield project. You may be working in a different environment in an enterprise, and you may not be able to use third-party services. I totally understand. Again, it's just a principle that I kind of wanted to share with you. So why did we choose to build a serverless system rather than that traditional web server approach? And what benefits has it brought us? Well, first of all, number one, rapid time to market. So early on, we were very resource constrained, and we didn't have a big team. And kind of all of our funding was from our cash flow. And we had 4 weeks to build our entire system from scratch. And this included signups, payments, course video delivery, delivery practice exams, discussion forums, so on and so forth. Basically, all the LMS features you would expect. And if we had taken that traditional web server approach, I believe we would have never made it, and we wouldn't have had the business we have today. Secondly, we needed to scale fast and effortlessly. When we decided to build our platform, we already had tens of thousands of users on Udemy.com taking our courses. So we knew that when we launched our platform, we would need to scale really, really quickly. We wouldn't have that typical kind of slow trickle startup thing where we gradually acquire users. We would need to scale quickly. And we also knew that we would have very large spikes during sales periods like Black Friday. And so, for example, Black Friday 2016, our load was 40 times our regular day, right? So we did 40 times as much business as we do during a normal day. And it's amazing that our system, we didn't need to do anything. We didn't need to provision any additional kind of compute capacity. The platform scaled for us. We also wanted to offer a disruptive business model, right? We're doing something different. Instead of paying for thousands of dollars in personal training, in-person training, our customers pay $29 for a course and they keep it forever, right? It's just one purchase, lifetime access. And I don't think we could have done it without Lambda and AWS, because Lambda, as I said to you before, we only pay for the time that our Lambda function executes. And Lambda executes once when our user goes to take a course, and that's that. And I think, and again, I know that this is recorded, but I think it costs us roughly 14 cents to deliver a course to a user once a user buys that course. And most of the cost is actually in the data delivery, right? So that's kind of very interesting. And this allows us to not charge those kind of ongoing fees that others may charge. And this has really enabled our business model and fueled the growth of our business. The cost is disruptive. And look, one of the advantages to the serverless approach is that existing applications can be gradually re-implemented to serverless architecture. So if you're faced with a monolithic code base, you can gradually just pull it apart, right, tease it apart, and create Lambda functions that your application can communicate with. Serverless doesn't have to be an all-or-nothing proposition. So the system may have to be a hybrid, but that's okay. That's totally fine. You'll still get a lot of benefits. Some cons. Look, it is not for everyone. Services like Lambda run out of a public cloud, so if you're building a mission-critical application, like a patient life support system, for example, then you may require a higher level of performance and reliability than a public cloud can provide. Obviously, there's service levels and customization. AWS has SLAs for certain things, but not for others, so you have to consider that as well. Is reliability offered by AWS good enough for you? It's good enough for our business, but it may or may not work for your business. There is that other issue of vendor lock-in, and I totally agree with Mike that the vendor lock-in issue is not in the Lambda functions. Lambda functions are easier to port across. You can wrap your Lambda function in an Express framework and run it on your own server. It's not a big deal. The issue are the other services that you may integrate with in a public cloud like AWS. How are you going to port across S3 and Kinesis and DynamoDB and all the other services that your serverless application could be using? So that's something you have to consider. And of course, decentralization. If you move from a monolithic approach to a more decentralized serverless approach, you're not automatically reducing the complexity of your system, not at all. In fact, the distributed nature of the solution can introduce its own challenges, because now you're making remote rather than in-process calls. And so you need to handle failures and latency across a network, like you would with, say, microservices. Of course, there are a lot of pros. Why you would go with a serverless approach? The big one is no more servers to manage. So you don't need to think about server configuration and management, patching, maintenance. All of that is taken care of by the vendor. And let's say Amazon, in our case, looks after the health of its fleet of servers. And it has to make sure that capacity is provisioned for us. Versatility. We have found that serverless architectures are very versatile. So we have built backends. We have built event-driven pipelines. We process a lot of data. We have chatbots that we've built. You can do all kinds of things, and you can do them really quickly. Low cost. I've said this to you before. You are only paying while your user is doing something useful. If your user isn't using your system, then you're not paying anything. So that's interesting. Whoops. Sorry, I jumped across. And of course, there's scalability, flexibility, and we have found that our system actually has less code, which is interesting. So we kind of built our system, and it was awesome, and it scaled. But we realized something about our architecture. Yes, it was serverless, but it was actually a serverless monolith. Why? Well, it's because we had one database, Firebase, and everything was coupled to it. So all of our Lambda functions would write to this database, which was okay. It got us to market. It created our business. But it presented a number of challenges. First of all, we wanted to bring in a mobile app, and that was hard to do. We didn't really have a version consistent API. We also used CloudFormation for the AWS parts of our system, but there was no CloudFormation for Firebase, right? It's a Google product. It's made by another vendor. That was hard to manage. And how would we kind of scale from a few developers that we had to 10 developers, 20, 50, without everybody kind of stepping over one another and dealing with a single code base and a database? So this is what we have, right? We have kind of our cool little serverless system. We have our Lambda functions. We have our database, and everything works okay. But how do we grow? Where do we go from here? So we decided to move to a microservices style architecture. So where each distinct business domain is represented by a separate microservice. And each microservice is responsible for its own view of the world. It has its own database and its own API. And this has allowed us to achieve acceleration with highly focused teams that own and are accountable for one particular aspect of the system. And it allows us to actually scale various parts of our system separately. So we can allocate different read and write throughput capabilities to DynamoDB, depending on the different levels of demand that we may experience. And so here's a very simple example, right? So this is our learning record service. So we have a request. It comes through to the API gateway for that particular microservice. There's a little Lambda function just above the API gateway. That's our custom authorizer. It authenticates the request. Then the API gateway invokes a Lambda function. That Lambda function writes something to our source of truth, which is DynamoDB, which is a DynamoDB table in this example. So again, every microservice has its own database. But the action of writing something to the DynamoDB table invokes another Lambda function, which then goes and updates Firebase, which is, as you remember, our old Firebase that we used, which is coupled to our user interface. But now Firebase is basically used as a materialized view that drives our UI. There are no smarts in this database. We don't do anything really with it. We update the database, we denormalize everything, and that simply updates our UI. So what happens is, again, we have our source of truth, which is our DynamoDB table for this particular microservice. And then we have Firebase, which is that materialized view which drives our UI. And again, everything is push-based and event-driven. As soon as a change is made to Firebase, everything updates. We also use Algolia, which is an awesome search service that you can use to kind of provide search capability for your application. I actually implemented cloud search on AWS, and don't go there. Don't try it. Again, sorry, Chris, if you're here. So there you go. And when you think about it, we've migrated from this serverless monolithic architecture to microservices without actually having to think about infrastructure. We haven't had to think about server provisioning or web farms or load balancers. We changed our architecture by changing a YAML file in a serverless framework. So we use a product called Serverless Framework, which allows us to kind of organize, orchestrate, and deploy our entire application in one go. And yeah, so we define our architecture in that one file, or number of files, and we hit deploy, and our system can be created at a hit of a button. One other thing to think about when going serverless, managed services are moving targets, right? You are building against a set of managed services. So for example, Firebase made their old version obsolete, which forced us to upgrade suddenly. Node 0.1 support was dropped by AWS Lambda, and that forced us to upgrade. We had no other choice, right? Amazon said, sorry guys, we're turning off support for Node 0.1 tomorrow, and well, it wasn't tomorrow, we had a couple of months to do it, but we had to do it. So you have to consider that. We had a bug that showed up in our deployment because Auth0, so another service that we use, introduced a library change, like a minor version, and that had a bug in it. And that forced our application to have a bug. So yeah, look, it sounds amazing that you can create all these services and Lambda functions and have this awesome scalable architecture, and you can, but you do have to consider and think about the kind of the icky parts as well. So look, I want to tell you that this is a worthwhile thing to have a look at. This is fun. Even if you do it in your own spare time, create a Lambda function, hook it up to something, create a serverless chatbot. It is really just fun to do. And I think you will realize, as you work with it more and more, you will see kind of the power that you get from it. And you will, I think, identify aspects in your day-to-day job where you could use a serverless approach as well. So I run a conference called ServerlessConf, and we are going to have videos from all the speakers who attended our most recent conference, which was last week, on YouTube. So you can just go to video.serverlessconf.io, and you'll see all the videos there. We'll have a number of great talks by people like Mike, for example, Charity Majors, Chris, who just presented before as well, Tim Wagner, who's the head of the serverless team at AWS. So great talks. You will see lots of different perspectives, debates. This is still a very new area. Look, every one of you can still become a pioneer, can be a pioneer in this. And like Mike said, we haven't discovered all the patterns and all the architectures that we can build with this approach. So I kind of urge you, get into it, build something, share with the community, blog about it, because you can be that next pioneer, the next Dijkstra that kind of leads us forward. I didn't know how much time I would have, and I thought maybe I'll run out. I will have too much time left, so I added a couple of pictures from the conference. So we did it. This conference was held at the ZAC Theater in Austin, Texas. So Mike performed on stage, and I hope he enjoyed the experience. It's kind of weird being on stage and having everybody up in front of you. So here's another picture. Here's another picture. I think that's Austin Collins. Final plug, we do a number of workshops on serverless architecture. So if you are interested, please come and talk to me. And look, that's it. This stuff is fun. So look, get your hands dirty, build something small, go with it, and yeah, give it a try. Thank you for listening.